In the following demonstration, we will see how PLM Collaboration Services opens up the power of the 3D Experience platform for generative design. So let's start with a motorcycle designed in CATIA V5. We save that to the 3D Experience database, but keeping V5 as the master. Once we've done this, we can browse the CATIA data. So here in the web app, we get full access to all the data related to the current motorbike project. You can browse and navigate the structure, create new components to add to the project. Some of these could be 3D Experience components, some of them could be V5 components. As we navigate, there are some tools, for example, to understand ownership of the model. They are displayed in 3D Play, an application which allows you to view your models in a web browser without needing to have 3D Experience CATIA or CATIA V5. Here we're going to focus on a subset of the motorbike. We don't need all of it, just the environment necessary to redesign the swing arm in the 3D Experience platform. We're creating what's called a design space, an envelope based on the geometry of the original part. We can mesh it automatically with the Exploration Assistant from GDE, Function Driven Generative Design. We need to create some functional regions, the regions that cannot be changed. These are at the front and rear of the part. And then we define the critical load conditions that the part will experience, such as heavy braking, high acceleration, and we can validate that initial design space. Then we go to the optimization setup, where we can define some targets such as maximum stiffness and optimize for frequency and so on. Then we work on constraints to have more control and to drive the optimization in the right direction, such as making sure the part doesn't have more displacement in certain areas, to add maximum stress to your part, to refine control of fasteners and how they react. For the shape controls, you have manufacturing control to ensure your part is manufacturable with traditional processes such as casting or milling. Or you can give it more freedom and aim for a part to be created by additive manufacturing. In this case, we'll aim for a mid-plane symmetry, as the load cases are symmetrical. Once done, we can compute the result. In this case, we used additive manufacturing, so you can see the result is rather organic. The geometry is solid, so we can apply any CATIA geometric operation and standard CAD behaviors. This is not just a cloud of points or an STL format, it's real. On top of that, we can validate the part to ensure that it meets the KPIs that we want. And this is the first of many variants that we can compare using the trade-off study tool. This is very important because it allows you to view and evaluate concepts and then select or further refine your designs. In this case, we've chosen a version that can be easily milled, and then there's a version for additive manufacturing. And now they're side by side. Of course, once we've completed our design, the model can go back to CATIA V5. So that concludes this short demo. We've seen how we can now generate better products by being able to explore optimized parts. We've seen how it uses an intuitive workflow for designers, not for specialists, and how we can achieve the automatic generation of function-driven shapes. Of course, while doing this, we can continue to use CATIA V5, and also we have extended the value of our existing CATIA V5 data by exposing it to a much wider community. And in summary, we do all this by supplementing existing processes with 3D Experience CATIA.